Welcome to the program. I'm Jeff Schechtman. The not-so-subtle joke has always been that the two things that were inevitable are death and taxes. And while efforts are always front and center to conquer disease and extend our life, the inevitability of death has always loomed large. Even efforts to regenerate life and the fascination with cryogenics acknowledge the idea of death. Now a whole new group of scientists are trying to defy the very evolutionary idea of death itself. The funny thing is that it's not happening in the great halls of medicine, not at NIH or Cleveland or Mayo Clinic or our great research hospitals, but in Silicon Valley, where a group of wealthy boomers, not unlike aging politicians, I guess, will do anything to avoid stepping aside. My guest today, author and journalist Chip Walters, writes about this in his new book, Immortality, Inc. Chip Walters is a science journalist, filmmaker, and former CNN bureau chief. His books include The Last Ape Standing and Thumbs, Toes, and Tears. His writing has appeared in numerous publications, including The Economist and The Wall Street Journal, and it is my pleasure to welcome Chip Walter here to talk about Immortality, Inc., Renegade Science, Silicon Valley Billions, and the Quest to Live Forever. Chip, thanks so much for joining us.
Well, thank you for having me. It's a pleasure.
It's a delight to have you here. Why is this effort taking place and really being driven by Silicon Valley more than what we might consider traditional medical venues?
That's a great question. I think it's a combination of things. I think partly the academic world, tends not to, spend the money to attempt, really big problems like this. This is obviously one of the most difficult biological problems you could imagine. Also, strangely enough, the federal or the FDA doesn't consider aging a disease. And I guess most of us don't really think about it that way. And so it took a couple of people that both had the money and the will to step outside the box and say, why don't we just leap over all the other diseases that we're trying to eliminate and eliminate the one disease that seems to cause us the most problems, and that's aging.
And really, Ray Kurzweil, as you talk about, was at the forefront of this. He was the one that really said, let's do this. Maybe there is some way to really address this issue. Yeah.
I mean, well, Ray is well known for going after big problems, and he's been a very successful entrepreneur and inventor. And so, a long time ago, almost 20 years ago, he was really already thinking hard about whether or not we had to age. And I think he made some interesting, he made a good case, for a scientific case for how this might be possible. Now, he's an engineer. He's not a biologist or a doctor, but, that's the way he thinks. And he kind of laid a lot out and he had a big effect on Silicon Valley. He's been very influential on other thinkers in Silicon Valley, like Larry Page at Google.
How much of this is driven by ego to some extent, the idea of just these guys wanting to live forever?
Well, actually, whenever I spoke with, we can get into the characters more, but I would say Ray is the only one that actually said, maybe Aubrey de Grey as well, who said, I personally intend to live, forever. I'm going to find a way to stop aging. People like Art Levinson, who's the chairman of Apple, is involved, and Craig Venter, they want to simply solve the problem. They see, and Aubrey de Grey does as well, they simply believe that this is something that's killing 150,000 people a day, and we should stop it.
And talk a little bit about the approach, how they're looking at the idea of death almost as a disease that can be cured.
Yeah, absolutely. I mean, that's precisely the way they're looking at it. I mean, I suppose we all sort of think, well, I age, and therefore, that's just what happens. It's the natural sort of thing that happens. But the truth is, if you truly understand and can get a handle on the biology of aging, and even maybe understand the evolutionary reasons why we age in the first place, then it is a biological problem. And you could look at it as incredibly complex disease, but a disease nevertheless, and get to the bottom of it. And you think these folks are all tackling it in different ways, but they are making progress.
And talk about the evolutionary aspect of it, because really it's evolution that sets the stage for the aging process.
Yeah, absolutely. Every living thing seems to have some kind of an age limit. Although, one of the things that came up in the course of writing the book is research that discovered that some animals don't seem to actually age. They do die. I mean, death will get everybody eventually if it's a lightning strike or a bus hitting you or something like that. But certain animals simply seem to defy aging. And that was one of the reasons why at Calico, for example, the company that was largely funded by Google, began to look at the possibility that, if that can happen in nature, and if evolution hasn't required that everything age, then maybe we should find out what, is happening in those animals' DNA and see if we can do the same thing in humans.
And what has the research to date shown in that regard?
Well, there are these other animals. Calico has found that, for example, naked mole rats, which I have to tell you are really some of the ugliest animals you've ever seen, but they're little small rodents, and they don't seem to age. They live 30, 35 years, whereas your average rodent lives 3. One of the interesting things that first came up in my discussions with Levinson and the people at Calico was they started looking at an animal called orange roughy. Most of us probably have bought and eaten orange roughy, but they're very similar to another fish, perch. And perch, again, they die after about 3 years. Orange roughy live 300 years. Bowhead whales live over 200 years. The Greenland shark lives 500 years. These are animals that are, as far as we can see, they don't get cancer. They seem to just kind of regenerate the cells in their bodies and continue to live until something else gets them.
And what has been the approach, the scientific approach, in going about this?
Well, there's a whole lot of different approaches that have been taking place. I mean, at Calico, they're really trying to understand the underlying reasons why we age. What master switches cause any animal, particularly humans, to age? And are there ways to flip those genetic switches to stop it? Bob Hariri, who's a neuroscientist at Cellularity, is one of the companies that I talk about in the book. He is a stem cell expert. So what he's trying to do is, get a handle on how we can turn what are called pluripotent stem cells, the kind of stem cells that can become any cell in your body, and use those to be either injected into the body or pills and create medicines that can recharge certain parts of the body. So if you have bad arthritis, to repair your knees or your back, to repair organs that are damaged, if your heart is failing, to boost that, rather than opening people up and trying to do dangerous surgery. And I believe that those are some of the earliest, kind of the first wave that we're going to see in really extending life in a way that we're healthy. We're not just continuing to live, but we're actually healthier. Craig Venter, who, is one of the characters in the book and was key in sequencing the first human genome, he believes that we need to get as much information as we can possibly get about the human genome. So he'd been working on trying to get 1 million sequenced, integrated human genomes so you could really understand what all of those switches in our genetics are telling us that they do every day. Our genes run everything about us on a daily basis, and they do millions, billions of things, every day. He wants to really try to understand what's going on, what are all those interactions, and if we can truly understand it, then we can figure out how to slow and eventually reverse aging.
Is there an inherent conflict that has evolved at all between the kind of work that these guys and their surrogates are doing and the more traditional medical establishment?
Well, again, one of the problems that, academic medicine has with this is, first of all, they don't generally get handed $1.5 billion and all the time and resources that they want. I mean, it might get a few $1 million here or there to really go after a problem. So I think that's one of the issues. One of the other issues, as I mentioned, is it's not considered, it's not considered a disease. So, in academic medicine, you kind of have to look at a particular specific problem. So it might be a particular kind of cancer, or it might be something like sarcopenia, which is muscle loss or muscle wasting disease, But everyone eventually gets sarcopenia because as you age, you begin to lose muscle mass. So some scientists, both in the academic community and outside the academic community, are looking at issues like that. They're trying to say, well, okay, let's see if we can cure sarcopenia. We may help people that have this disease, but we also could help slow aging if we could solve that disease. The same thing is there are cells in the body that just kind of wear out and become what are called senescent. And that means they basically are like zombies, and they neither die nor and regenerate nor really operate very, very well. So all they do is damage. Are there ways that we can go in and tag all the senescent cells and get rid of them? And there are some people that are working on that. But again, they really have to tackle it in the pharmaceutical industry. No one's going to really back something if you can't get an FDA trial and move the trial forward. That's just the way the system works. But in cases like Human Longevity Inc., Craig Venter's company, and Calico, Art Levinson's company, they can say, well, we've got the money. We're just going to solve the problem the way we think we need to solve it.
In a way, it's kind of the ultimate inequality in that all of this is being done with private resources, and those that arguably might have access to the success of any of it would be those that could afford it.
Yeah. Well, I try to address that in the book, because I think one of the first concerns that anyone has is, great, this is terrific for rich people, but it's really not going to be very helpful to me. I think ultimately, though, and particularly in the case of, and I also believe, there's been, an acceleration in the number of companies that are now getting into this business, because obviously it's a huge market. So if you solve aging, whoever can in any way reduce the pain that people feel in aging, or actually solve the problem, will make lots of money. But I do think there are major incentives for reducing the cost of helping people live longer. Insurance companies, for example, really don't want to pay lots of money for people to get ill. They want them to stay healthy. They'll do much better if that's the case. But so, it's a complex issue. If you take things like the automobile or television or radio or computers or cell phones, they were all incredibly expensive at the beginning, and mostly they didn't work very well. But eventually, as they got better and more people bought them, then the price started to drop. In the case of the human genome, 20 years ago, it cost $3 billion to sequence one human genome. You can now get your genome sequenced for $1,000, and sometimes you can get it for free because your doctor will just say, we need to have your genome sequenced. So I do think that eventually costs will drop, and I think that they'll drop pretty fast. And I think it'll be normal, for example, in the next couple of years for everyone to have their genome sequenced. So hopefully this isn't going to be just for the rich, although I'm sure there are people out there that are rich that are trying to, just for their own personal gain, keep themselves alive and really don't care if anyone else does or not.
Is there a fundamental difference of approach here? For a long time, it was always thought that so much of the research into specific diseases and cancers, I suppose, most specifically, that if that research could be successful, if we could understand what caused those diseases and ultimately how to cure them, that would give us insight into dealing with and maybe stopping the aging process. This is approaching it from a kind of different perspective, looking at the aging process first and foremost.
Yeah, it kind of flips the model if you think about it, because most people, when they get, let's take cancer as an example, most people, if they get cancer, get it because they're aging. The vast majority of, of course, we hear about children that get cancer, and that does happen, but it's far more rare. Mostly, we get the diseases that we get, whether it's heart disease or cancer or diabetes, because we're getting older. It happens when you get past the age 60, 65. So the idea here is that if you can solve the underlying reasons why we're aging, then you could vastly reduce all of the number of diseases that we get when we age. So again, it would, could potentially save, millions of lives, because you're not getting heart disease, you're not getting diabetes, you're not getting cancers.
How successful have these efforts been to date?
Well, it's not like there's been a silver bullet, that's been found. I think that here's why I think they're making progress. I think, first of all, we're getting a much, much deeper, better understanding of the human genome, and we have very powerful computing systems that are being developed to better understand how the genome works. An example that comes up in the book is with the creation of Human Longevity, Inc., Craig Venture's company. He said at the beginning, he said, I want you, he got together with all of his computer scientists, and he said, I want you to be able to tell me what somebody looks like based only on their genome. I don't want to see you take any pictures of them. I want no other information except a human genome. And they all told him he was crazy. And he said, well, go for it. It took them 8 months, and they broke the cloud, according to Venture, and just because they were dumping so much data into this. And at the end of it, amazingly, they created remarkably accurate images of the way people look. So the point is that the information in your genome is there. You just have to, really get the right data, get the right computing power, put enough money into it, and eventually you will get to the bottom of what makes the genome tick. Or at least you'll have, let's put it this way, probably a better way to put it is you'll have a much, much better understanding of it. So I think that that's moving forward. But I think, as I mentioned, I think the first wave is going to be in stem cell therapy, because basically what that does is it boosts what the body automatically already wants to do. You don't need to understand. It's helpful to understand more about the genome, but it doesn't require that you truly have to understand every little thing about the genome in order to make progress. Cellularity and Bob Hariri's company, he's the guy that first learned that placental stem cells are unique, and placental stem cells come from the placenta, and it turns out that mostly whenever a child is born, that placenta is just tossed in the garbage. And Hariri said, well, wait a second, let's take a look at that. And what he discovered was they're just loaded with pluripotent stem cells. And so you have this reservoir of stem cells that could be used for anyone. That would create no immune problems, no reactions. You just have to figure out how to create the medicines for it. And he has gotten over $300 million to develop those medicines. And we're already starting to see some advances in stem cell therapy. People's shoulders are being repaired, people's knees are being repaired, and even some hearts are being repaired. So I think that's where we'll start to see some advances. And what that's going to do is it's going to buy time until some of these other advances in the human genome and then the underlying evolutionary reasons why we age are advanced. And I think computing power is going to be the thing that drives a lot of that. And you know, you have to do good science. One of the things that Art Levinson said from the beginning when Calico started was he said, we're just going to go back to ground zero here. We're not going to build on anything else that's been done because, frankly, I don't think really good work has been done. And so, you know, they have over 100 scientists that are on it, and they're working every day at it.
Isn't one of the biggest problems just the fundamental evolutionary idea that we are built to age?
Yeah. Well, you know, it's a philosophical, in some ways, philosophical question, but it's definitely a biological question. For some reason, long ago, evolution sort of decided, I mean, evolution doesn't really decide, but the forces that shape evolution for some reason decided, look, rather than keep one animal alive indefinitely by continually, you know, rebuilding it, kind of buffing it up all the time, we're just going to let it live for a while, basically long enough for it to create another version of itself and then die. And that's what happens, you know. Now we are in this remarkable place, and this is really why I wrote the book, because I asked myself, are we in a place in human history, in natural history, where a creature can actually figure out how to change its own evolutionary destiny? You know, are we at that place in human history where we're going to do something that extraordinary? And so I decided, well, let's see if that's true and see if we can track these people down and see what they're up to and why they're up to it and tell that story, because to me, it's just a really, really good tale.
How much conversation is there among all of these people that you've mentioned, that you've talked to in the course of research and reporting this book, about the broader sociological and moral consequences of this effort?
It depends on who you're talking to. Someone like Ray Kurzweil, who's a great optimist and believer that human intelligence and human technology can solve virtually any problem, and he's tried to, you know, create those advances himself. He believes that we will ultimately solve problems like overpopulation, like the way we're damaging the planet, how we handle disease, you know, that we're a smart species and that we can figure it out. Someone like Art Levinson, who is a microbiologist by training and, you know, was also the CEO and chairman of Genentech, the first biotechnology company. I asked him about it, and he said, you know, my job as a scientist is to solve the problem. He said, I can't speak for the rest of society, and it's really not my place to speak for the rest of society. Society itself has to decide, you know, what its priorities are. He said, but what I'm focused on is trying to solve this particular problem. And that's why they've got over 100 people working on it. Craig Venter kind of half-kiddingly said, well, I guess we're going to just have to neuter half the men in the world. Don't think that he meant himself, and I also don't think that he really expects that to happen. But, you know, it's one way to reduce the population problem. You know, but you can still consider, you know, continue to live a long time. So, you know, I don't think it's always a big question that comes up. And one of the reasons I wrote the book was because in the course of writing it, I realized, oh my God, I think these guys are really going to pull this off. And if they do, it's going to capsize all of human society. So maybe we better start to think about this, you know, and think about how we're going to handle it as a society. I don't really advocate one way or the other with it, but to me, it's a little bit like, it's a much more it has much more impact, but it's a little bit like the invention of the car or the radio or all the other things that I mentioned. You know, these are things that were created once. You could say nuclear power too. You know, once Pandora's out of the box, it's out of the box. You can't put it back in. And I don't really think there are very many people that if you walk up to them and said, you know, I can help you live a better, healthier life. You know, you're not going to be decrepit. You're going to have energy. You're going to be able to do things that, you know, you didn't think that you'd be able to do. Would you rather die? I think most people will say, no, I'll go for living longer. I mean, we do it all the time. If you find for the cancer cure or something, we don't say, no, I'll pass on that. I'd rather die of cancer. You try to stop it and live as long as you can. So I think that's what's going to happen in society if we begin to make advances like this. And so I hope that one of the things I hope that comes out of the book is we'll start to think about this.
Which really begs the question as to whether or not all of these guys that are involved in this and spending billions of dollars in resources on it should carve out a small amount of those resources to create, whether it's think tanks or call it whatever you want, to begin to simultaneously study the broader consequences of this that go beyond just the medicine and the science. Right.
No, I agree with that. If I have the opportunity, I'll bring it up with the people that are in the book. I don't think that right now people have started to think about it because I think it's just beginning to dawn on even them that this is a real possibility. And unfortunately, human beings often wait until trouble arrives, you know, and then we go, oh my God, let's fix the problem, you know. And look how well we're handling climate change. So we're still debating whether or not there is climate change. So I suppose we'll have some kind of debate at some point that says, we're not all going to live that long. You know, this isn't really going to happen. I mean, really, again, if you want to look at the facts, 100 years ago or 120 years ago in 1900, the average human lifespan was 47. It's now pushing 80. And, you know, a lot of people are living longer than that. So in a way, we're already facing the problem. So this would just accelerate it.
Those that are working on this finally, what do they see and what is your sense of what kind of time horizon they're looking at?
Well, when I first sat down with Art Levinson about this, and and by the way, all the information about Calico, Google, and everything that's in the book is exclusive to the book. Nobody else has ever spoken with Art Levinson or anybody at Calico about this. But when I first started to speak with him, he said, and in fact, he told Larry Page this, and the meeting is in the book too. He said, this is an incredibly difficult problem. It could take us, we might get lucky and it happened in 5 years, but more likely 25, maybe 100 years. Maybe it'll never work. He did finally conclude in the course of, while I was working on the book, that yes, it can be done. Aging can be solved from a biological point of view, which was a huge breakthrough in itself. But you know, we just don't know how quickly it's going to happen. Again, what I think is that we're going to see a first wave in stem cell therapy within the next 4 to 5 years. There might be a big breakthrough that takes place in the next few years. Arthur Levinson has intimated to me that they do have some trials that they are very enthusiastic about right now. Exactly what those are isn't clear yet, but perhaps we'll know soon. So I think we're going to see some serious breakthroughs. It's not like we're looking 50 years down the road. We're looking 5 years down the road. But it won't be a silver bullet.
Chip Walter, the book is Immortality, Inc., Renegade Science, Silicon Valley Billions, and the Quest to Live Forever. Chip, I thank you so much for spending time with us.
That was my pleasure. Thanks for taking the time to talk.
Thank you.